Today I'm going to be working on a power supply. This thing just died. These are actually fairly reliable power supplies. The only problem with them is the fan sometimes dies, which is natural. They're in a fairly dirty environment. So today we're going to pull it apart, replace the fan, clean it up, and see if we can't get it to work again. It is worth noting that some of the components in here, if they are energized, could give you quite a shock. So be careful. We are fairly dusty in here. So this is the fan we're going to replace. So this is a 3-wire fan, and so we have to replace it with a 3-wire fan. It's 12 volts, it's 80 millimeter, and the RPM is about the same, so this should be a perfect replacement. So this was a NMB 12 volt DC 0.29 amp brushless, and we're replacing it with an Ascent 0.20 amp 12 volt, also brushless, and this should work just fine. And with this, we can still blow this off, but we want to make sure that we're not like blowing components off, so just light air. And to clean it, I'm just using rubbing alcohol. This is 99% because we want it to evaporate quickly. Now there's always the possibility that there's a component in here that failed, but so far, I mean, we've been doing this for quite some time, and 100% of the time we replace a fan and it works. So hoping that's going to be the case today. I think this is mostly just like insulation material, like a glue or an epoxy from when they manufactured it, so not too awful worried about any of this material that's on here. Something like this. I could leave a lot of wire on here, but we really don't need to. The more wire that we have, you know, we have to have a place to put it. So I'm going to try to make it somewhat short. These are butt splice connectors. I'm just going to use these crimp style connectors. I got these Klein crimpers. They're cutters and crimpers. They work great. You want to make sure that you're installing the fan the correct way. Essentially, the open side is going to go over here. The closed side, the grate, is going to go on this side. So we can put it underneath the screw. You don't really want to crank it down because you can just bend the case. Just want to make sure that all these fins are on the inside. These plates might not want to line up just right, so I might have to persuade it a little bit. Okay, so now it's ready to test. So here's something that Frank invented. So this is just a load. Essentially we got 2 lights here, 1 light here. They're each 12 volts, so if you put them in series, 2 of them makes 24 volts and 3 of them together makes 36 volts. We have a 24 volt and 36 volt power supplies. This one's 24 volts, so we're going to be using 2 lights to make a 24 volt load. So we got the load, now we need the line. So this is 115 or 230, it doesn't matter. So he made up these. These are test lead wires, so it's super flexible, much better than like a stiff wire, because these could potentially try to like spring out. This, wherever you put it, that's where it's going to stay. So this stuff is awesome. And this is the test panel that he made. So I'm going to plug in. So this will be my line. And then I'm going to use the ground for my neutral. Got this assortment of Alligator clips. Doesn't really matter which one we use, we just want one that's strong. That'll work. Okay. We got a spade on one side, we got Alligator clip on the other. That'll work. So I'll put that on there. Should go to the neutral, but we don't have a neutral on here, so I'm just using ground. So let's turn it on. We have got power. So at this point, we're just going to let this run for about 3 hours. If it does, we know the power supply is good. Put it back in stock. All right, so it's the end of the day. It's still running.